this video, I'm going to talk about the mean. The mean is also called the average. Now, it turns out there are several different types of average, but the mean is the most common one. In this video, I'm going to try to give you like an intuitive understanding of the mean. There's a cute little visual we'll do here with these people holding their ice cream cones. And then I'll explain the mean a couple different ways, one of which will lead us directly to a nice formula, which we won't actually talk about in this video, but it'll help you understand the formula. I'm also going to talk about the main sort of, I guess, thing that the mean is not good at. Okay, so we have our three little friends here who've gone for ice cream. And this little friend with a very long arm gets 2 scoops of strawberry. This little friend gets 1 scoop of vanilla, and this friend gets 3 scoops of chocolate. And so the way we can find the mean is we have our 3 numbers here, 2, 1, and 3. And we just want to redistribute these so that they're shared equally. The mean is like the fair share number, where if you took these, the 2, 1, and 3, and you shared them. So if our chocolate ice cream eating friend gave a scoop to the vanilla ice cream eating friend, then there now everybody has 2 scoops. And so the mean of these numbers, the 2, 1, and 3, the mean is 2. Now I want to just do the same thing a slightly different way. And I think it's important, it's not necessarily obvious to people in the abstract that if you do this the different way you'll get exactly the same thing. But when you see it with the cubes, it becomes obvious. So the other thing I could have done is I could have just said, here, just give me your ice cream for a minute, and taken all the ice cream. And then I could have gone and shared it back out and divided it into the 3 groups. Right? And that, of course, that gives us just the same amount, that 2 scoops per person. Okay, so there's one example, calculated 2 different ways. I'm going to do 3 examples altogether. In the second example, our strawberry ice cream eating friend still gets 2 scoops, and the vanilla 1, but they were out of chocolate that day. So our chocolate ice cream eating friend doesn't have any. So with the first method, if we take the mean of 2, 1, and 0, we just pop that over there, and the mean is 1. And with the second method, we say, can I have your ice cream for a second? And we collect it, and then we hand it out. And of course that also gives us 1. Now I think it's important with these 2 examples, the reason that the mean is useful and that we're interested in it, it really feels like, if you ask these people, like, how much ice cream did they have? Well, 2 scoops, 1 scoop, and 0 scoops. But the mean of 1 scoop, that's pretty close to what most people sort of felt they had. It's exactly what the vanilla ice cream eating friend thought they had. It is what they had. And 2 scoops is pretty close to 1, and 0 scoops is pretty close to 1. All right? So these are pretty close to most people's sort of experience about their ice cream cones. And that's why, if we talk about sort of an average, this is what we want. We want one number that represents sort of a variety of numbers. So we want a number that's kind of in the middle, for some sense of the middle. And we want it to be reflective of the numbers in the group. And in these cases, I think the means are really reflective. Everybody having 1 scoop is pretty close to the situation that we had here. All right, we're going to do another example. So the next day, the 3 friends go to the store again, and they do in fact have chocolate today. And so our chocolate ice cream eating friend goes a little bit overboard and just keeps getting more and more chocolate ice cream here. So much that it won't even fit the building. The chocolate ice cream eating friend has this absurd amount of chocolate ice cream. All right. Now, if you think about what most people's experience is here, before we actually find the mean, this person feels like they have sort of a medium small, like a regular kind of amount of ice cream, and that's what this person's experience is too. That like most people feel like they have sort of a regular, smallish, a nice size of ice cream cone, right? But when we have one extreme case, then that's going to really have a big effect on the mean. So if we share these out, and as we saw with the last examples, we could also put all the ice cream together and then split it up. If we share this out, then all three of our friends, the mean here is to have 5 scoops of ice cream, which is a huge ice cream cone. Now, I bet if you ask the strawberry ice cream eating friend, how much ice cream do you feel like they have? They'd say sort of a medium, regular amount, which is not, I don't think, very well represented by these 5 scoops of ice cream. So I think this is a case, the mean of these numbers, the numbers were 1, 1, and 13. The mean is 5, but I don't think that 5 here is a very good representation of how many ice cream scoops most people sort of felt that they had. So this is one of the disadvantages of the mean. If you have a bunch of numbers and then a really extreme number thrown in there, which we call an outlier, it really throws off the mean. And which is fine. If these friends really are sharing their ice cream, then that's great. If they come out of the store and they split the ice cream and then each of these people goes away with 5 scoops of ice cream, then that really is reflective of their experience. So sometimes the mean is a really good number to use to show sort of what the irregular average thing is. But if they're all eating their own ice cream separately, and the strawberry and vanilla eating friends are just watching the chocolate ice cream eating friend eat this ridiculous ice cream cone, then maybe the mean is not a very good representation of how much ice cream these people have. All right, so I hope you learned a little something about the mean.